Hi, I'm Hussein, 12 years old, Primary 6 from YUMIN Primary School. So for this time, we're still going on with ordinary differential equations. But in this time of ordinary differential equations, I'm going to do a little bit more of explanation with an example. So firstly, I'll tell you this example. Then while I'm solving this example, I'll tell you all these explanations. Let me just tell you, I'm going to explain more from characteristic equations. So this example, y second derivative, okay, so it's here, plus y, and this is 3e to the power of 2x. Okay, firstly, in the past, when we meet these types of questions, we've always said, this is non-homogeneous. But at the same time, it is linear, it is constant coefficients, it is an ordinary differential equation. Okay, so what we can do is we want the general solution. We want the general solution. General solution is yg. So we split it into general solution for homogeneous differential equation. Let me write that down. That is YH. And the other part is the particular solution for non-homogeneous differential equations. That is YP. So this YH. YH, that means you have to let this whole part just be equals to 0. Okay. Here's the difference. In the past, we have always said, just use characteristic equations. But when we just use characteristic equations, you might be wondering, how do we get this name? Why do we call it characteristics equations? Why must we name it like that? Okay, so let me tell you right now here, why do we have to call it characteristic equation? So, firstly, characteristic equation. The first word, characteristic, comes from character. So, let's first understand what character means. Okay, think for a while. Okay, now let me tell you. Character, for this case, the definition we needed is actually something like a distinction, something like a property, something like a trait. And what does these do? These allow us to differentiate or distinguish one thing from all the many others. So that means these are special. These are just unique. These are distinct. As these, for this right now here, I write it in a homogeneous form. This is linear. You have constant coefficients. Well, this part is what that makes it special. Apart from all those others, these type, linear and constant coefficients, are those that you only can solve. Those others, right now I'm saying about characteristic equations. But I'm still telling you about how it comes from. Okay, so let's assume that right now we don't know that method. We're still in the past. Okay, but we have already learned the substitution method. Okay, so let's make a substitution here. So let's make a substitution. Now, how can we substitute? Well, that's another problem here. Because on one side, we need all of them add, these two add up, makes it equal to 0. How is that possible? Okay, right now I have a few cases here. So let me write them down. And let's think here. So first part, sine x. Well, sine x is possible because sine differentiates 2 times, then you get negative sign. So that's possible. Next case is a cosine. Well, cosine differentiate 2 times. It's also correct. Third case, this thing differentiates itself, it's still itself. That is e to the power of x. Right now, in these three cases, which one of them is the best? Let's first think. Sine. Sine can only get sine and cosine, just these two converting to each other. Cosine, well, it's still sine and cosine just converting to each other. How about exponential? Now, you have to be really careful. Exponential, not only itself, you have to be aware. You can even use the imaginary number. So, for example, you put e to the power of ix. Now, what do you think of? E to the power of ix. Of course, it will be the Euler's formula. So, the Euler's formula is actually, well, if it is positive like this, then you'll get cosine x plus I sine x. Well, if this power is negative, then it's just cosine x minus I sine x. Now that means exponential not only can get exponential itself, but also sine and cosine, all at the same time. So this exponential is the best. Okay, so that means you'll make this kind of substitution over here. But for this part, we'll just let this part be lambda. But can we put a c here? Yes, you can. You can say that there's a constant over here, but when you start in, what happens? Front part, top of this lambda. Then c e to the power of lambda x. Back part here, no change. Now what happens? These two parts simplify. Well, just like this, that means whether you put c here or not, it's just the same. Because at last, it was finally all simplified. Okay, now until this step. Now what is this step? At this step, what do you get? This is lambda squared plus 1, and it's equal to 0. First thought that might come to your mind, isn't this a quadratic? But let me tell you, no, that's not what I want to say. Because this is just a special case. This is just a special case whereas you get a quadratic equation. Other cases, I can put third derivative, I can put fourth derivative, I can put hundredth derivative. They all can. So what can we call it? Polynomial? No, I don't want that kind of answer. But I can say that this is an algebraic equation. But how many variables in this algebraic equation? Well, only this one variable. So only this one variable in this algebraic equation. This part. And from here, this is whereas we get our characteristic equations. So, now to get it, what's so special about this thing? Well, because, firstly, this part is linear and constant coefficient. What if this is not linear? For example, you get this part square, then suddenly this part square root. If you make this substitution, here you suddenly get c squared e to the power of 2 lambda x. Then here you get half of that. Well, no, you can't simplify it. And if you can't simplify it, useless. Okay, so this first part is if it is non-linear. But how about constant coefficient? Well, constant coefficient, if you suddenly put x here, for example, you suddenly put xy, then this part, the x, then you get all messed up. So no. So this is so special about this characteristic equations. Okay, so let's see. Now this part back to normal. Well, this part is simple. Okay, so I think I can erase this part right now. So that means this part, you get 2 roots. Since this is a square, so you get 2 roots, okay? First root. You move this to the other side. Square root, positive. But this is a square root -1. Square root -1 is the I. It's the imaginary number. Okay, then next, after you square root, there are 2 cases, positive and negative. So the second root is the -I. Okay, so these are the 2 roots you get. Next part, just sub it inside. So you just let this y, well, if you want to specify this, you can say, I want YH. But y is also can if you want. So YH. That means this will be, first part, C1, e to the power of ix. Excuse me. The next part, C2, e to the power of negative ix. What do you think of this? Okay, I purposely erased that. Well, right now we use Euler's formula. We can try to get in sines and cosines. Okay, we use Euler's formula. What happens here? So that means this part, C1, here it becomes cosine x plus I sine x. This part is just here minus. That means it becomes like this. So then we can try to rearrange them again. For example, cosine and cosine. C1 plus C2, just combine them. You can get C3. There's sine and sine. But be careful. I here, well, you can just take I as a constant. So that means you can just write there C4 sine x. Okay, you can just write it like this. You can write it like this. But what if I say, one person, so you get sine x? Well, the best is actually write sine first and cosine, okay? So, this part I can change it a little bit because the best way to write it is sine first and cosine. Since we usually say sine cosine, but it doesn't matter here right now. So you can change it like this. Okay, like this, much better. So from this part, what if one person suddenly gets sine? Only sine. Because when you sub it inside, sine differentiate 2 times the negative sign, so it cancels with itself. So what's the big matter here? Cosine differentiate 2 times also cancels with itself. So you get one of this is correct. Get the other part, only, is also correct. But which is the best? Well, of course, this is the best. Since it's complete with all its parts, there are no parts missing from here. Let's say you only get sine. If you only get sine, then that means you miss out the cosine. Then if you only get cosine, that means you missed out the sine. In either of these 2 cases, that means your answer is incomplete. This is the complete answer. Okay, so this is the general solution for homogeneous differential equation. So it's like this. Okay. Next part is the particular solution for non-homogeneous differential equation. This is the next part. We still have to let. Here in this part, we want e to the power of 2x. Now, how can we get e to the power of 2x? But you have to be careful. Here is just y. So maybe yp is a e to the power of 2x. Or you can write it like that. So this part says there are no overlaps with this part. So yeah, it's fine. But do we need to find first derivative again? Well, you can straight away skip the second derivative if you can. Since this part is easy, you don't have the product rule, you just need a chain rule here. So that when you differentiate 2 times, then 2 of these 2 come down. So it's 4. Then that just start back inside here. And you get 5a e to the power of 2x would be 3 e to the power of 2x. And here you just basically get 5a is 3. So a is 3 over 5. And that means yp. That would be 3 over 5 e to the power of 2x. That means you've got both parts already. So then the complete answer for yg would be, firstly is this part, c3 sine x plus c4 cosine x plus 3 over 5 e to the power of 2x. So you get all these. Okay, so until this part, you're actually done. If you want to verify, you can verify yourselves. So this part, I just write it out completely, as this is the first time this kind of question came up here. So in the future, if we meet this type again, we can just straight away write it as this. Okay, so in the future, if you meet that kind and you suddenly don't understand, you can come back here and watch this again. Okay, so let's check this part. Okay, so all of these are fine. So for this part, the most important part right now for this homogeneous is that you have to understand the characteristic equation. Where did it come from? Why do we call it characteristic equation? Okay, so this lesson, I think I can end it here. So I hope that you all can understand. So if you like our videos, don't forget to subscribe to our channel. So we'll see you in the next video, and thank you for your watching.